let's start doing this high-level question. It's robot collisions. So here you are given zero index array partition and the three array. So you can see here, and then the arrow for left, R for right, and all integer in partition is unit. The partition is unit. So all robots start moving on the line simultaneously and the same speed in their given direction. If two robots either share the same position while moving, they will collide. Okay. So two robots collide, a robot with the lower health is removed from the line. Okay, who have the lower health, just remove it. And then the health of other robot decrease by 1. Okay, and the surviving robot continue in the same direction it was going. Okay. If two robots have the same health, they both remove from line. Okay, so your task is determine the health of robot that survive the collision. In the same order the robot were given, final health of robot 1 is if survive, the final health of robot 2 if survive, and so on. So there are no survivor, return any empty array. Okay, return array contain the health of remaining robot. So I think the question is a little bit just is easy to understand. Just how to achieve, how to find the remaining robot. It's the this question challenge. Now you can see here, because owner robot in the same direction, so that's why owner robot needs to return. We need to return owner robot. And here, the second example here, you can see first we need to sort it, and then we can find, because we need to sort it based on the partition 2, 3, 5, 6, right? So you can see the position is random order, so we must be sorted, and we will get different order, right? Now you can see these two robot is moved to the right direction. This last two robot go to left direction, right? So now we need to compare these two, right? Because they are in a different direction, so we need to compare it. So, but we know these two robots have same health, so these two robots need to remove from line. And then the first robot need to compare the last one. So we know the first one is bigger one, have a higher health, right? So the last one need have to remove from line. So the first robot need to the health need to be decreased by 1. Decrement by 1, right? Now let's see how to solve this question. Actually, we can use the stack, right? So before we have one thing need to know. If we got this one, so we know the two robot will move to right direction, and this robot go to the left direction, right? So we need to return this alternate, because the test case is only one direction, which is return alternate. So which means how to make collision. So if the robot have right direction and the other robot, so I mean the robot have right direction in the left hand side, and then this one another robot have the right hand side, so we can make collision, right? Otherwise we cannot make any collision. So it's the key point, because this robot can go to right, this robot can go to left, so that's why we need to it's the collision, right? So now how to solve this question? So we can create an array. So we know here have 4 elements, right? So we can create an array. The array also have 4 elements. So it's 0, 1, 2, 3. We need to fill out each box with its corresponding index like 1 0 1 2 3. This one's in index 0, which means the index will point to the position. The index will point to the house. The index 0 will point to the direction, right? So it's very helpful to combine everything together. And after that, now I already mentioned we need to sort it based on the partition array, right? So we create one more array. It's more, you can more easily to understand. Now we know 2 point to here, right? Because 2 is smaller position. So the index 2 come first. And the 6 point to the first index 0, right? So this one should come after 2. And then we just use this way to sort it. And then find is 1 and then 3. Okay, after we sort it. So here we need the stack. Actually, we don't need to use a stack. We can use array, which is same as the stack. Now, is I use the as represent the stack. So, but the stack only store on the right hand side, right direction. Which robot have the right direction? So the pointer we point to here, you can understand is -1. Okay, we have variable. Now, if we make the robot who have right direction, so we put in a stack until we make the robot who has left direction, and then we can do. If we here already have the robot here, which means we need to make a collision between both robot, right? We need to compare who they are in the same house or in a different house. And so now we find all the name. Now we need to go through this array. We need to go this one. So we can start from here. Because we know the index 2 with the layers a smaller position, right? So now we need to check the index 2 from direction string 2. So we need to find where is the direction. It's R, right? Okay. So I told you before, this star array store the which robot have the right direction. So we know it's right direction. So here we put the index here. If we put index here, we can easily keep track of which robot is, right? Now we point to last index, point to here. Let me use the pink. Now we point to here. Let's check what is the direction of the robot. So here, we found out it still have right direction, right? We put in an index here. Now point to here. Now we come to here. We need to check where is the direction. So we can see it's L, right? Okay, which means we have 2 R in the 1 L, right? From the currently. So we know, I mentioned before, the right direction, the robot must be in the left hand side, and here should be in the right hand side, and then we can make collision. Now we define this requirement. Now we need to compare who has the smaller house and who will be removed from the line. So now we got the index is 0, the index 1. So let's comparing 1 and the 0, right? So these 2 robots have the same house. So which means we need to remove these 2 robots from the line. So we can here directly change to 0, which means, okay, remove from line. Now we do the next. We pointer point to next one. Oh, 1 second. Point to here. Oh, I forgot here because we need to remove from the stack. Now we check this one. Now 3 is position 3 is index 3. We need to check. Okay, index 3 is L. Okay, now here we become period that we already removed. Now we got a lot of robot have left direction. 1 second here. So now we need to make collision, right, for these two robot. And then left this robot have their health is 12. Then this robot have and 15, right? So we know this robot has more net health, right? So we know this robot needs to remove from the line. So here need to 1 second. It's a little bit messy. Now we need to change this one to 0, which means it's removed from line. And then because this one is 15, right? So we need to decrease by 1. So here become a 15. Now finally when we finish all the we already reached the end, right? So we need to go through this health array one more time. So which number is greater than 0, which means we need to return the robot. So we know we still have one robot having the 14 health, right? So we return this one. So you can see the output is 14. Now let's code it up. So here we need to. So first step we need to create and we need to get a size position. And then we need to create array called indeed. Oh, sorry, it should be integer. If we didn't use integer, we cannot use the sorted built-in sort method. So here, now we need to create array. We need to fill out the corresponding index. So now in this I equal to I, and then we need to sort it, right? In this, and we need to sort it based on the position. So A, B, and then we need to use the lambda expressions. So it's position A minus position. Oh, 1 second. Now when we finish sorted, we need to create a stack, right? So but we can stack new in the end. So I told you before, the stack only store robot who have right directions. Okay, now let's code it up. Oh, sorry, here's semicolon. Now let's start here. We also have pointer. We can call it top, or we call this right. The right should be start from -1. Now we need to go through this array to find do we have two robot have collision or not. So here we need to create I in this. Now we need to check if their direction I equal to L. Now, if this one is not L, which means we need to pull the robot into the stack, right? So stack top equal to I, right? Now here we need to check. We make sure top is not equal to -1. If the top still point to -1, which means we don't have any robot who have right direction, right? So we cannot do any collision. Oh, sorry, he's right. Now we need to create the stack right. Now we have three conditions, right? First one, we need to have I equal to health J. So if these two have same health, which means these two robots need to remove from line, right? Now I equal to 0. Equal to 0 means the robot is removed from line. And equal to line, right? Now, because here J, which means which robot have right direction, we need to decrease because the pointer is point to, for example, here still have index, which means still have robot. So when we finish this one, we need to remove this one from the stack. So we need to point to previous one. So the right need to equate and break, because we point to, for example, we point the pointer here. If they are same, so which means this robot finish its work. So we need to break, because it's while rule, right? If we didn't break this one, the final will cause time limit, something, the error happen. So here, next thing, which means because we know this one robot is smaller than this one, so here should be assigned by 0. This one should be decreased by 1, right? And then because this robot, which means is the robot who have right direction, so but this one is the pointer, the array here, because you lost here, so we need to break the while loop. Now here third direction, so this one is smaller than this one, right? This one is bigger one. So now, which means this one should be assigned by 0, right? And then this one need to decrease by 1. They have to decrease by 1, and then the top, because not, for example, the robot still here, but you lost your precision, so now comparing the previous robot. If we still have a robot alive, so then this robot still need to comparing. So sorry, it's right. Now after here, we finish all the name. We need to find which robot still survive. Yes, integer, right? And then we need for this one, A, and we'll check the health. If A is still greater than 0, so which means we need to add it. Now we need to return that. So you can see in the past on the test case. Okay, almost big 100%. And the time capacity is here. I run the array one time, and I sort it. So that's when I sort it, which means the time capacity is b of n, and I also use the extra memory and go through here. The time capacity, because we need to pick the bigger one, bigger time capacity. So here is bigger. So now finally the time capacity is b of n log n. The space capacity also is b of n. So thank you for watching this video.